Well, I must say I think I have finally figured it out with the help of Jim Murray's dissertation in 2013 and 2014 on his Dynaflux alternator concerning oscillating power. What happens here is that the neon bulb has nowhere to go. That's why this free end here, this metal wire, is not made into a larger surface area. We don't want that. We just want a little piece of wire there. A token gesture to let the electricity know, you could have gone here, but you know what? Screw you. You're not coming out this way. It has nowhere else to go but to go back down to ground and oscillate back up and go back to ground and go back up, provided the connection with ground is sufficient to engage the earth. Otherwise, we don't set up any oscillation because it doesn't have a polar opposite to go to. Everything in here is balanced, and this is balanced with that. In other words, the load is balanced with the AC inverter. Actually, no. The load doesn't exist. This in here is balanced with the AC inverter. And the neon bulb could balance it with ground itself if the ground was connected. Yeah, this is just another lobe. Comes along for the ride. That gets carried along for the ride, provided this oscillation gets set up. And so this is why I said somehow, quote, somehow, the high frequency stimulation of disruptive discharge happening up here, fueled by this relationship in here, creates a voltage surge down here because it's oscillating. And that's what creates the voltage surge. If we didn't measure this, we wouldn't know that there's a voltage surge happening up here as well. See, everything in here is regulated by this. So the only oscillating surge that can occur is between the neon bulb and earth ground. But this is connected to this inner portion here. And Jim Murray said that current can carry power without affecting voltage, which is pretty interesting. So this oscillating voltage surge must set up a rise of current in the electric keeper in here that funds the load over here. Well, I've said before that there's somehow a monopole going on in here, so that the load becomes the other end of a dipole, one end of a dipole, the other end being this whole circuit basis in here, so that the load can dictate the so-called creation of power, when in all likelihood what we're creating is a controlled parasitic transient of oscillations in which the power is not going back to the inverter. It's oscillating between ground and the neon bulb. Just the fact that it's oscillating creates movement, and that movement alone would boost the amperage in this electric keeper. So that's how that works. So I don't know if I can agree with Jim Murray that voltage is not involved. Oscillating voltage is the predicate for a rise of current, appearing seemingly out of nowhere. We get paid once for the voltage difference that's set up between the power station and our appliances. And then that voltage difference causes a one-time passage of current, of amperage, from the source to us and back again. But if we create a controlled parasitic transient of oscillating surge of voltage going back and forth here, perpendicular so to speak, to this direction in here, which it normally would go from the AC inverter to the load, with a high enough frequency of oscillating voltage, it's practically no oscillation, in a sense. This load, if it's sufficiently low enough in its frequency, AC frequency, won't see this. It'll just see the movement going back and forth, which gets translated into this movement here, which is parallel to this movement here between the load and the AC inverter. So it's very clever how this is set up. I think this is exactly what Jim Murray had specified in his Dynaflux alternator. In his earlier experiment, the synchronous capacitor, that I made note of in a video, an outtake of one of his video packages, dynafluxalternator.com. I think it goes from like 43 minutes to 55 minutes. It's something like 11 or 12 minutes long excerpt. And he said he ended up, the net effect. See, I thought the cause was he doubled the voltage. No, that was the net effect of this oscillating current that he set up. See, I didn't understand from dim memory, or the first time I heard the lecture, what was going on, because I never heard of oscillating current before. And it took me a while to understand parasitic transients are oscillating currents that are out of control. But if you set up one that is in control, provided your line can carry it, and that's why this electric keeper has to be 4-gauge wire to handle the amperage buildup that occurs in here. And that's why all your connections have to be properly done, so you don't send the amperage somewhere else other than where you want to send it and fry that particular wire that's not the proper gauge to handle that surge of amperage. Clarence warned against this. Somebody had the wrong connection, and he said, well, I think it was the primary, and he said you're going to fry your primary because he didn't say why. Just because, he said, there was the wrong connections. Well, because the amperage buildup from this oscillating current has to have somewhere to go, right? We don't want it to go to load. It'll probably fry the load. So we send it to the electric keeper, because we can put as much as we want to in there, so to speak, within limits, obviously. So we send it to the electric keeper, and the AC inverter, it regulates the primary on these two toroids, so it can't go back to the AC inverter, and nor does it have to. It's not forced to go anywhere. It can stay very happily zipping around in here, some of which bleeds off and powers the load. So somehow, see, this is the next unanswered question, somehow the load regulates the surge, the oscillating surge of voltage that's oscillating here between the neon bulb and the earth ground, so that when the load goes down, this goes down, and when the load demand goes up, this goes up to match it. And of course the link between this and the load is the electric keeper in between, the amperage build up and die off. Because if you took out the load, if you turned off the load, this whole system would go back to idle mode, and the amperage in here would drop accordingly, and the oscillating surge of voltage would also drop accordingly. So it's an oscillating surge of voltage that's happening here, not a flow of current, not a flow of amperage. That happens in here to make up the difference. Because we know, amperage and voltage are tied together, so we have somewhere for amperage to manifest. I kind of suspected that between these two toroids, the power manifests, but I didn't quite understand how or why. But now I can understand. It's very simple terms. Very simple. And you can't say it's power we didn't get charged for. If this was the power company over here supplying us with AC, it's just that they're, as Jim Murray says, the pricing structure would have to be restructured, because they're only charging us for one-time usage of their electricity. He was working for Bethlehem Steel to cut their costs, because their inductive loads of their motors, just to build up the magnetic field of the motors before they could even begin to operate, to push gravel around, had to borrow electricity from the power company, which they were being charged for, even though they were turning around and giving that power back to the power company without even using it for anything, just starting up the motors, getting them up warmed up before they could even move gravel. When they moved the gravel, then you would think that's when they should be charged, billed by the power company. But they were being gouged to the tune of something like, what was it, $150,000 or $15,000 a month? I mean, it was a huge additional charge to their electric bill. So they asked him to look into it, and he looked into it by creating a synchronous capacitor. And Eric Dollard has talked about this. Putting a capacitor, he didn't say what kind, putting a capacitor outside the meter, between the meter and the power company. Well, I don't know where Jim Murray put it, but he put it, and it saved them thousands of dollars a month because they weren't being billed for energy that they were not being used, they were not using. They simply borrowed it, was his phrase. Well, I don't know, warming up a motor sounds like, in my opinion, you should be charged, but what the hell, what do I know? Maybe because when the motor dies down, that's what he meant by borrowing. When you turn off the motor, the field collapses, and you effectively are now running that motor as a generator, sending power back to the power company. So yeah, he's right. You're merely borrowing the energy, other than losses. Okay, other than losses, you're borrowing energy to create the magnetic field of the induction-style motors. They're all induction, right? I don't know if they're anything other than induction. Well, they're not electrostatic, whatever. So you're borrowing the energy until that field collapses when you turn off the motor. And that's when the borrowing cycle is completed, because you send the energy back to the power company because your motor is now operating as a generator. Well, it's operating as a generator all the time anyway because of back EMF. So in a sense, there's a lot of inefficiency in the usage of motors, and that in itself is a component of billing that should be subtracted from energy consumed because it's energy produced, sent back to the power grid. Anyway, so I understand Jim Murray's philosophy and thinking, and so we are recycling energy, and so it would require a different billing, obviously, because we're getting multiple uses out of that same block of energy that we're getting from the power company. We're using it twice, 3 times, 4 times, until we shut off our load, and then it goes all back. So we would get the most benefit out of this circuit if we didn't just keep turning it on and off all the time. And that's probably why Clarence said he always idles this, and he never turns it off. He just turns off, no, he said he turns this off when he turns off his loads. Why was that? He didn't want to be charged extra electricity for just idling this? Yeah, but he was running it off as battery. Ugh, ouch. Sorry, my arm's being strained. This is completely isolated from the power grid. Maybe he said he turned it off when his battery was charged up. I can't remember now. But he did say he turned it off when he wasn't using the load. I think it was for safety reasons. Well, in the case of the power grid, if this were coming from the power grid rather than from the battery, I don't know. I'm not going to go there. I can't speculate. I don't know. So that's what's going on in here. It's simply oscillatory power. And now I can safely stick my neck out and say so on the Barbosa and Leal forum and not care, again, what Clarence says. Because A, anything he says is constructive criticism if I can figure out how to apply it. If I feel in my heart that he has something worthwhile to say or to contribute to me. You know, what he's doing for other people's benefit is none of my business. I'm in there to share, and if he wants to say this, that, or the other thing about me, so what? You know, if it's true or false, I'm not going to contest it or verify it one way or another. It makes no difference, because it doesn't make any difference. It's irrelevant. He didn't keep any secrets from me, and I didn't break into anything, so I just did my work. And if that's a crime to put in the work, you know, I put in a lot of work to read every single post of his, look at every single image that he posted. So I don't know what he's complaining about. I just simply did the work of researching what he put into the public venue. And if I'm guilty of hard work, so be it. And if I was guilty of complaining about the work being made more difficult by him, by making it harder to find things, then I'm guilty of that much and no more, of complaining, you know, being a whiner. It's because I did whine, in the beginning especially, until I learned to keep my mouth shut. But it's, you know, I'm guilty of hard work and guilty of a little complaining. Okay, whatever. So he's complaining. Now he's whining. It takes one to know one. Yeah, he's probably whining that he gave us too much information publicly. Whatever. I didn't steal anything. Good grief. He'll know better now for next time, right? Yeah, not to trust that everybody is mediocre and lazy and slothful. Once in a while you find somebody who's willing to do the hard work of research. And my research, of course, was just researching what he had already done. I haven't done any experiments of my own to speak of, although I have done a little. Even prior to me ever meeting him, I did my own sleep-style circuits in trying to investigate Tesla's special generator, and that's all documented on earthinglife.info. I even got a provisional patent, but nobody was interested in buying, so I had to give it up. I shouldn't have, but I lost motivation. Until a YouTuber made a comment, and that, Faith Ahura was her name, and she got me restarted again. So, oh, by the way, I ordered some neon bulbs, 15 no less. I don't know, to pay for the postage, I bought more than one. And so that should be interesting, and I went into storage and got some stuff out of storage. But the main thing I was missing was the neon bulbs. I have one in storage, but it's buried, and I don't want to go looking for it in another storage location. So I just ordered 15 more. It's not expensive, and I'm waiting for them to arrive from China. Or no, not from China. No, I think they are from China. Well, whatever. They're going to take a while to show up. Anyway. And then I'll be able to see what impact it has on the sleep circuit application of my partial rendition of replicating this circuit in a sleep environment, in an earthing appliance sleep environment, to try to get my feel, just a beginning, you know, wet my feet, wet my toes, to try to get a feel for what I'm dealing with here. But I can see, just by studying the material, I can see that I was already given the information, I wasn't making full use of it. And I suspected Jim Murray had something to offer me to learn from him. I just didn't understand what he was talking about. But when I recalled that Eric Dollard had made a vague mention of the use of a capacitor to lower his electric bill, it starts to make sense. And then the stories of the early DC power company of Edison in New York City over 100 years ago, and the problems they had, and they had to call in Steinmetz to fix them, it starts to make sense. It's very interesting. Something that's knowledge that's over 100 years old, that we literally have to reinvent with the help of people like Jim Murray and Paul Babcock, and Eric Dollard. We literally have to reinvent it, and Barbosa and Leal and Clarence. They're all swimming in the same swimming pool of an oscillating power system based on an AC power system. How do you make an oscillating power system off a DC? I wouldn't even imagine how you could do that. Maybe you can, you know. Maybe Nathan Stubblefield figured out how to do that. I don't have a clue, so I'm not even going to speculate. I'm in no position to. But how else did Nathan Stubblefield seemingly replicate what Barbosa and Leal has done? I don't see how else it could have been done. I don't know. We'll see. Or not. In time.